Good day, everyone. We are Group 1 and we're about to present Chapter 3, which is Research Methodology Measures of Central Tendency. Next slide, please. In this chapter, the objectives are: first, know the different statistical treatment that can be used in a research paper. Second, compute mean, median, and mode for questionnaire validation. And third, come up with the correct statistical treatment for the research paper. Next slide and next reporter, please.
Statistical treatment. Statistics. It is a numerical index describing a characteristic of a sample. Statistic is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of the data. A statistic or sample statistic is any quantity computed from values in a sample which is considered for statistical purpose. Statistical purposes include estimating a population parameter, describing a sample, or evaluating a hypothesis. The average of sample values is a statistics. Statistical treatment. A mathematical treatment used for summarizing or analyzing numerical data for information. The term statistical treatment is a catch-all term which means to apply any statistical method to your data. Treatments are divided into two groups. Descriptive statistics, which summarizes your data as a graph or summary statistic, and inferential statistics, which make prediction and test hypotheses about your data. These statistical methods allow us to investigate the statistical relationship between the data and identify possible errors in the study. In addition to being able to identify trends, statistical basic statistical treatment. Next slide and next reporter, please.
Number 1, measure of central tendency. In statistics, it is a central tendency of value or a typical value for a probability distribution. A. Mean. The most common measure of central tendency. It is simply the sum of the numbers divided by the number of numbers. So the formula in getting the mean is um, number of population is equals to summation of x divided by n, or a number of value. Or for example, scores 1, 2, 3, 6, 8. If you add all of that, 1 plus 2 plus 3 plus 6 plus 8, you get the number of 20 divided by the number of numbers, or which is 5. So the answer we will get is 4. Therefore, 4 is the mean in the given set of scores. Next slide, please. Median. It is the middle value in the list of numbers. To find the median, your numbers have to be listed in numerical order from smallest to largest. Example, the scores 13, 13, 13, 13, or 14, 14, 16, 18, 21. The 14 is the median because it is organized in a smallest to largest. And therefore, we get the middle of the scores. Next slide, please. And letter C, mode. It is the value that occurs most often. If no number in the list is repeated, then there is no mode for the list. Example, scores 13, 13, 13, 14, 14, 16, 18, 21. 13 is the most frequent number. Therefore, the answer is 13. Next slide, please. Standard deviation. It is a measure of the dispersion of a set of data from its mean. When we say standard deviation, to get the formula of standard deviation, population standard deviation is equals to square root of summation of each value from the population minus the population mean squared over the size of population. That is the formula for standard deviation. Next reporter, and next slide please.
F-test and t-test. When we say p-value is a probability of getting result as extreme as observed values under null hypothesis. For practical purposes, reject a null hypothesis if the p-value is less than alpha, or generally 5% or 0.05. When we say p-value is a statistical measurement na ginagamit upang patunayan ng isang hypothesis at kung tama ba ito. Sinusukat din ng p-value ang probability na makuha ang mga na-obserbang resulta sa pag-aakalang totoo ang null hypothesis. Kung mas mababa ang p-value, mas malaki ang statistical significance ng na-obserbang pagkakaiba. So when we talk about t-test naman, this is used to find out if the means between two population is significantly different. When we say t-test, it means ay isang univariate hypothesis test na inilalapat kapag hindi alam ang standard deviation at maliit ang sample size niya. Characteristic of test. Number one, the test statistic follows at distribution under null hypothesis. Second, the test can be used to find out if the mean of population is different from a known mean. Third, the test can be used to find out if the mean of two samples are significantly different. Note that two populations need to follow the normal distribution. Also, the variances of two population need to be wait lang, equal if sample size the less than 30. 4. The test can be used to find out if the difference between values of a single variable measured at different times is 0. 5. The test can be used to find out if the regression line has a slope different from 0. 6. Paired versus unpaired. A test of type 3 is a paired test. The sample are independent. A test of type 4 is an unpaired test. In many cases of unpaired data, it is the same variable undergoing repeated observation. For example, measurement taken before and after an experiment. And last, the question that need to be answered before using the t-test are, it is a single population or multiple population? Are the sample sizes equal? Are variances equal and it is paired of unpaired? Next reporter, please.
F-test. Tests are statistical tests used in hypothesis testing to determine whether the variances of two populations or samples are equal or not. So what are the characteristics of an F-test? First, the test statistic has an F distribution under null hypothesis. The ratio for variances follows an F distribution. Second, F-test can be used to find out if the means of multiple populations having the same standard deviation differ significantly from each other or ANOVA. Third, F-test can be used to find out if the data fits into a regression model obtained using least square analysis. Here we compare if the mean square due to error is significantly different from the mean square due to regression. Fourth, the test can be a two-tailed test or a one-tailed test. Fifth, the F-test for ANOVA for two variables is equivalent to performing the t-test. Also, the relation is given by F equals t squared. For ANOVA, the F-test is the measure of ratio of variance between groups and variance with the sample groups. So what is the F-test statistic formula? F statistic is equal to variance of the group means divided by mean of the within group variances. So next reporter po.
Analysis of variance ANOVA. This is a statistical technique that assesses potential difference in a scale level dependent variable by a nominal level variable having two or more categories. For example, an ANOVA can examine potential difference in IQ scores by country, US versus Canada versus Italy versus Spain. The ANOVA, developed by Ronald Fisher in 1918, extend the and the C tests which have the problem of only allowing the nominal level variable to have just two categories. This test is also called the Fisher analysis of variance. The came from the word of the who developed the ANOVA, Ronald Fisher. Next, please, next. General purpose of ANOVA. Researchers and students use ANOVA in many ways. The use of ANOVA depends on research design. Commonly, ANOVA are used in three ways. First is one-way ANOVA, second, two-way ANOVA, third, n-way multivariate ANOVA. Next, please. One-way ANOVA. One-way ANOVA refers to the number of independent variables, not the numbers of categories in each variable. A one-way ANOVA has just one independent variable. For example, difference in IQ can be assessed by country, and country can be 20 or more different countries in that variable. Next. Two-way ANOVA. A two-way ANOVA refers to an ANOVA using two independent variables. Expanding the example above, a two-way ANOVA can examine difference in IQ scores, the dependent variable, by country independent variable 1 and gender independent variable 2. Two-way ANOVA can be used to the exam interaction between the two independent variables. Interaction indicate that differences are not uniform across all categories of the independent variable. For example, female may have higher IQ overall compared to males, and are much greater in European countries compared to North American countries. Next report, please.
Chi-square. This is a non-parametric test of statistical significance that is used when research data are in form of frequency counts or for two or more categories. A chi-square statistic is a test that measures how a model compares to actual observed data. The data used in calculating a chi-square statistic must be random, raw, mutually exclusive, drawn from independent variables, and drawn from a large enough samples. A chi-square statistic is one way to show a relationship between two categorical variables. In statistics, there are two types of variables: numerical, which is the countable variables, and non-numerical, which is the categorical variables. The chi-square statistic is a single number that tells you how much difference exists between your observed counts and counts you would expect if there were no relationship at all in the population. And that would be all for Chapter 3, Research Methodology Measures of Central Tendency.